Hi learners, welcome. In this video I am going to tell you a simple trick to calculate or to convert grams to moles. So in stoichiometry, how to convert given grams to moles. So in general we use formula to convert grams to mole is given weight, generally they used to give in grams, should be multiplied with moles of the substance whose moles you want to calculate divided by gram molecular weight of this substance in grams. This formula in general we use to calculate, but here I am going to tell you a simple trick to calculate stoichiometric conversion of gram to moles. So the trick is so simple. It is, so whatever the given weight of substance they have given, you take that given weight in grams, divide it by and write its gram molecular weight. Take this ratio. Again it is in grams. So then you are going to get a constant. Let us say that constant as A. A is the constant value that you are going to use to calculate number of moles of each and every substance. So now you just multiply this with any of the substance whose moles you want to calculate, that into its stoichiometric quotient. Then it will give you number of moles. Let me explain this with simple example. So in a problem they asked you to calculate number of moles of substances that are reacting with 39 grams of nitrogen and hydrogen forms ammonia. What they told you, 39 grams of nitrogen is reacting with hydrogen, not and. Nitrogen is reacting with hydrogen and forms ammonia. So to solve this, what you have to do first is you have to write a balanced chemical equation. Nitrogen is reacting with hydrogen and forms ammonia. Okay, so in this case, how can I balance this? 2. 3 times 2, 6. 3 times 2, 6. It's a balanced equation. Always you have to take a balanced equation. Then only you will get stoichiometric quotients. So this is balanced equation. Then where are the stoichiometric coefficients? 1. This 1 is a stoichiometric coefficient of nitrogen, 3 is for H2 and 2 is for ammonia. So if you want to calculate each and every element, they may ask you only one, but I will show you here how to calculate each and every element stoichiometric quotient. I mean number of moles. How many moles of N2 is reacting? How many moles of H2 is reacting here? How many moles of ammonia is forming? What I told you, they gave in the problem only the weight of nitrogen that is reacting. How much is reacting? 39 grams. So how can I find A? How can I get A value? A is equal to given weight 39 divided by what is that? Nitrogen. Nitrogen gram molecular weight is nitrogen 14 plus 14, 28. That is equal to grams gets cancelled. You are going to get a constant value. And what is that constant value here? 1.39. So this is important. This is a trick that we did here. Now how can I find first one? Number of moles of N2 is equal to what I tell you. Take A value 1.39, multiply with stoichiometric quotient 1. That will give you moles, 1.39 moles. So what is the answer for this? 1.39 moles. Similarly, I can calculate number of moles of hydrogen. Anything I can calculate in this balanced equation. So what I have to take? A value 1.39 should be multiplied with its stoichiometric quotient 3. So that is equal to 4.17 moles. Answer is 4.17. Similarly, even I can do for ammonia also, but in this case what I have to do is simply I have to multiply with 2 because stoichiometric coefficient is 2. Moles of ammonia is equal to 2 multiplied by 1.39, that is equal to 2.78 moles. Just write those values. So answer for this is 2.78 moles. So in this way, if they gave a molecular weight of any given weight, you can use and you can calculate constant like this, and each and every reactant and products moles can be calculated by using this simple trick. This is one way, one type of problem. They may ask you without giving this equation type, they may ask you only a single element. For example, 63.5 grams of carbon dioxide, convert it into moles. Very simple thing. 63.5 grams of carbon dioxide, convert into moles. So in this case, there is no need to write balanced chemical equation because they didn't give other reactants or products. Only they gave carbon dioxide. How many moles? Only 1 mole. Whenever they gave a single molecule or substance, you can take it as 1. Number of moles equal to 1. And this formula can be used. Given molecular weight 63.5 divided by what is the gram molecular weight of carbon dioxide? Carbon 12 plus 32, that is equal to 44 grams multiplied by how many moles? 1 mole. That is equal to, you can do this calculation part, grams will get cancelled and you are going to get answer 1.44 moles of carbon dioxide. This is another type of problem. Generally they are asking on gram to mole conversion. Gram to mole conversion. If they ask such problems, you need to take only 1 mole because here they gave only 1 CO2, means 1 mole of CO2. So in this way, these two types of problems you can do. They may ask you to calculate any one of the elements moles, but I have shown here to calculate each and every reactant and products moles can be calculated by using this simple A value. So this is a simple trick to solve the problems based on conversion of gram to mole. Hope this will be helpful for you. Thank you for watching. Please subscribe to my channel.